Students, I explained the coordination complex explained by the Werner's theory. I already given the audio. Now I give that some examples to you. So this is the coordination complex. So what is the first point? Primary valence is oxidation state of the metal atom. So here the oxidation state of the metal atom is a CO3 plus. So what is the primary valency is a plus 3. So what is the oxidation state of the metal atom is a CO3 plus. So the primary valence is a 3 and the secondary valency is a coordination number. So what is the coordination number? That is a 6. So secondary valency is a 6. Coordination number, so it is a 6. It's a primary valence oxidation state of the metal atom, so it is a 3. Okay, and next is the primary valency is a positive and R 0. The primary valency, what is the primary valency? It's a oxidation state of the complex central metal atom. So oxidation state of the central metal atom is a plus 3. Okay, so it is a positive. And also it is satisfied by negative ion. Which is the negative ion? Cl minus. So that the CO3 plus is satisfied by 3 Cl minus ion. And next, the secondary valence is satisfied by negative ion, neutral molecules and positive ions and combinations of these. I give the example to this. This is the coordinations complex. You have to convert the coordinations complex. You have to write like this. So you take this. Here the secondary valency is a coordination number. So here coordination number is 6. That is a secondary valency. So secondary valency is of cobalt is a 6. Okay. So it is satisfied by this cobalt 6. Secondary valency of a cobalt 6 is satisfied by 6 neutral molecule, 6 neutral ammonia molecule. And here the second example. In this compound, 2 types of the ligands is there. So one is the amine ligand and another one is the chlorine ligand. Okay, so there are 5 amine NH3 and 1 Cl is there. So 5 here that cobalt secondary valency of the cobalt is 5 is satisfied by 5 NH3 neutral molecule and 1 is satisfied by the Cl molecule. Okay, so here the secondary valency of a cobalt is a 6. The cobalt is a 6, not a 5. It is a 6. So the 6 means it is satisfied by 5 neutral ammonia and 1 chlorine molecule. So totally 5 plus 1 6 molecules is there. Next, there are the 2 sphere. One is the inner sphere and outer sphere. So inner sphere is a coordination sphere. That is the inner sphere. The outer sphere is the ionization sphere. Okay. So here in this complex, this is the inner sphere and this is the outer sphere. So how can you put it in that diagram? So the central metal atom of the cobalt is there. Okay. This is the inner sphere. The inner sphere having the ligands. What are the ligands? 6 ammonium ligands. 6 ammonium ligands is located at the inner sphere. That is strongly bounded to the central metal atom. So it is represented as a solid line, and outer sphere it is a ionization sphere. That is ionization of the molecule is there. There is a Cl minus, 3 Cl minus is there. So it is represented as a dotted line. So why it is represented as dotted line means it is loosely bounded to the central metal atom, because nearest secondary valence is nearest to the cobalt atom, and inner sphere is nearest to the cobalt central metal atom, and outer sphere is long away from the central metal atom. So which is strongly bounded means it's nearest one. Nearest one is the inner sphere. Inner sphere is strongly bonded to this, and outer sphere is a loosely bonded to this. Okay, the outer sphere having the ionized molecules, and inner sphere one is having the ligands, and the ligands present in the square of this complex, that is there. The fifth point is suppose it is depend on the non-directional. The primary valence is depend on the non-directional. It is a secondary valency or the directional. That is a secondary valency only is determine the geometry of the complex. So secondary valence is 6 means it is a octohedral complex. Secondary valence 4 means it is a tetrahedral or a square complex. Thank you.